Hey guys, it's that time again. We're approaching the end of our unit, and so it's time for our practice test today and test tomorrow. This is the practice test for Unit 6. Can you tell? I got confused and thought it was Unit 5. And I wrote a 5, but then we're turning that into a 6. So this is Unit 6. Let's go ahead and get started with the first section. Now, as always, these practice test videos are a little bit longer because I'm going to do every single problem with you. So I do suggest you go ahead and try all the problems yourself first, check it against the answer key, kind of see where maybe your weaknesses and strengths are, and then use that knowledge to fast forward through this video and just find the material that you need. You're not required to watch the whole thing, just watch the parts of it that you need. I'm going to go in order so that it's easy for you to find what you're looking for. Okay, starting at the beginning. Write the specified ratio as a fraction with correct units. Simplify your answer if possible. Okay, so it says mice to horses. Now let's see, does it say how to write the ratio? Yes, sorry, it says to write it as a fraction. So you could write, let's see, mice to horses. That's going to be the 2 and the 3, right? So although it is possible to write the ratio like this, these are both not what we're looking for because we want the ratio to be written as a fraction. So we're going to write it this way, 2 to 3. And I should also include my units. So it's 2 mice to 3 horses. And you would just leave it like that. You should ask yourself, is this fully simplified? And the answer is yes, this is fully simplified. So we are done with this one. All right, let's do cats to ferrets. All right, looking over here. Cats is 8. We'll put that on top because it's the first one. So 8 cats to how many ferrets? 4. 4 ferrets. That's my phone over there buzzing. Can you hear it? So annoying. Okay, so 8 cats to 4 ferrets. Can this one be simplified? Yeah, it can. Both of these are divisible by 4. So 8 divided by 4 is going to give us 2. And 4 divided by 4 is going to give us 1. So it's 2 cats to 1 ferret. And don't forget the simplification. Guys, that is super important. You've got to simplify to get the answer right. It's right there in the instructions, and it'll be important on the test tomorrow as well. Let's go ahead to number 3, ferrets to dogs. So ferrets, it looks like there's 4 ferrets. And that is messy, sorry. And then dogs, 10. 10 dogs. Okay, is this able to be simplified? Yeah, it looks like both of those numbers are divisible by 2, so let's divide them both by 2. 4 divided by 2 gives us 2, and 10 divided by 2 gives us 5, and then just writing my units here. Okay, how'd you do? You're done with the first section. Let's go on to number 4. It says, use the following ratio in context to complete the problems below. Okay, let's see what they're talking about here. It says there are 4 presents for every 2 lumps of coal under the tree. Uh-oh, lumps of coal under the tree. That's not what we want this time of year. But let's go ahead and work our math problem. It says complete the table by writing this ratio and the next 4 equivalent ratios using larger numbers. Okay, so they want us to start with this ratio and then write the next 4 ratios. It says it may be helpful to find the unit rate, pay attention to labels and axes. I don't know why they're saying it might be helpful to find the unit rate first, because what they want us to do is start with the current ratio, which is 4 presents to 2 lumps of coal. Here's what I'm going to do. I'm going to look at my graph over here, because guess what? They labeled the axes for me. So just to make sure I don't mess it up, presents is X and lumps of coal is Y. They also wrote our titles here, so they're really trying to help us put the right thing in the right place. You can label that X and Y if you want to. You're not required to. Okay, so back to our ratio. How many presents? 4. How many lumps of coal? 2. All right, so you've got 4 and 2. So what about if we get another 4 presents? 4 plus 4 is going to give us 8. And then how much more coal would we get? We'd get another 2 lumps of coal, right? So 2 plus 2 is 4. And what I'm going to do is I'm just going to keep adding 4 presents here each time. And I'm going to keep adding 2 lumps of coal here each time. 12 plus 4 is 16, plus 4 is 20. Okay, so each time adding 4. And on this side, each time we're adding 2. So 2, 4, plus 2 is 6, plus 2 is 8, and plus 2 is 10. So each time, you don't have to write these little pluses off to the side. I just want to show you that each time I'm adding 2. All right, now if your table, if you did it before you watched this video, which I hope you did at least give it a shot, if your table looks different, it's possible that you did it totally right. And for example, I'm just going to write P here and L here, P for presents and L for lumps of coal. What if you started with 0 and 0 over here? That would be totally fine. Even if you went like this, 2 to 1, 4 to 2, 6 to 3. If your table looks more like this, I want you to think of that as correct, okay? There's nothing wrong with that. Okay. If your table does not look like this, don't worry about it. Perfectly fine if it looks like this one. Let's go on to number 5. Okay, number 5. Plot as many points as possible and draw a line connecting them. Okay. So presents are down here. Let's go to 4 presents and 2 lumps of coal. So 4 presents, 2 lumps of coal. Boom. Next up, 8 presents, here. 4 lumps of coal. 1, 2, 3, 4. Next up, 12 presents and 6 lumps of coal. 5, 6. And then 16 presents. How many lumps of coal? 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 20, 16, 17, 18, 19, 20. Okay, and there's the 8 was there, 9, 10. All right, there's all of our dots. Sorry, that one kind of left the screen there for a second. And then we just connect them with a line and put our little arrow on the end of the line, and we're done with the graph. Let's go on to part 6. What does 0, 0 mean in this situation? Well, it would mean 0 presents and 0 lumps of coal, right? So it means if there are no presents, then there are no lumps of coal. Now, if you had just said no presents and no lumps of coal, that's totally correct too. Okay, so no presents, no lumps of coal. Let's go to number 7. It says, draw a triangle to represent how you would move from one point to the other on the graph. Okay, so you're going to find one point and go to the next point with your little stair-steppy thingy. Now, I chose these 2 points, but if you chose this point and this point, that's totally fine. Every stair step that you draw between 2 points should give you the same answer. Even if you chose this point and this point way out here, that should still give you the same answer once you simplify. Let's keep reading. So draw your triangle stair step thing. Use the triangle to determine the constant of proportionality, that big long thing. So remember, for the constant of proportionality, they even tell you right here, you move vertically and then you move horizontally and you write it as a fraction. Let's do that together. So moving vertically is up and down. We're going to count with me, 1, 2. All right, so vertical is 2. That means we're going to put 2 on top. Now let's move horizontally. And again, horizontally is side to side, so count with me. 1, 2, 3, 4. And that number, the horizontal number, the 4, that goes on bottom. Okay, so now we have our constant of proportionality, but it needs to be simplified. So 2 over 4, both of these numbers are divisible by 2. So let's just go ahead and do that. 2 divided by 2 is 1. 4 divided by 2 is 2. So that constant of proportionality is going to be 1/2. Okay? All right, going on to number 8. How many lumps of coal are there for every present? Okay, so how many lumps of coal per every present? So we want lumps of coal on top and presents on bottom. So what I'm going to do is I'm going to take it, you could take it from the original words. You can take it from the original words, or you can take it from the table, whatever kind of makes more sense to you. I'm going to take it from the words. It says there are 4 presents for every 2 lumps of coal. Okay, 4 presents for every 2 lumps of coal. So 4 presents for every 2 lumps of coal. So it's kind of backwards. Originally I was thinking presents per lumps of coal, but here it's coal per present. So just make sure you're reading that carefully and putting the first one on top and the second one on bottom. So the coal on top, the presents on bottom. Okay, so 2 coal per 4 presents. Now we need to figure out how many lumps of coal there are for every present. So that bottom number, the presents, that needs to turn into a 1, because when you're saying for every present, that's like how many lumps of coal will you have for one present, right? So let's figure out how to use our equivalent fractions to get that number to be 1. So what did we multiply or divide 4 by? By itself, by 4, right? We did 4 divided by 4 to get to this 1. So we have to do the same thing to the top. 2 divided by 4, well, it's not really divisible by 4 in an even way, but when you divide 2 by 4, and you can certainly use a calculator if you want to when you're doing this. I'll do that just to show you. Get rid of all that. 2 divided by 4, you're going to get a decimal, 0.5, and that's fine. That's what you put there, 0.5. Okay, so now that you know this, the number of coals is on top, so this is the number of lumps of coal per every present. So you're going to say 0.5 lumps of coal for every present. Could you also say this way? Yes, you could say 1/2 lump of coal for every present. Totally fine. All right. Okay, so what equation represents this situation? So if they're saying how many lumps of coal per every present, then you need to write, okay, so it's always going to start with y equals, right? Y equals, and then you're going to say 1/2 x. Okay, and so we should show what the variables are now. Now the lumps of coal, the x is the one on the bottom. So x is going to represent presents. And the y is going to represent the lumps of coal. Okay, good. So basically, if you had, say, 6 presents, that's your x, you would plug it into this formula. You would do 1/2 times 6, and you would get, boom, 3 lumps of coal. Let's actually double check this with something from our table. Let's go for this biggest one. 20 presents, 10 lumps of coal. Okay, so our x is going to be our 20. Let's plug that into our equation. 1/2 times 20, because that's our x. 1/2 times 20 equals 10. Is that what our table said also? Yeah, it is. So it looks like our equation works, and that's really good. Okay, so that was that section. Let's go on to the next page. All right, we've got a lot of unit rate stuff here. Now on the front page, the unit rate wasn't really used at all. At least it wasn't mentioned as unit rate. But what were you figuring out here? It was pretty much the unit rate here, right? Because it was per every present. And it was the same thing here. Notice that these two numbers are the same. Is the constant of proportionality the same thing as the unit rate? Kind of is, yes. Okay, let's go on. Find the unit rate and round to the nearest hundredth if necessary. Okay, that's good to know. Label with the correct units. That's always good to remember. Okay, 50 lollipops in 4 hours. When you have something that looks like this, I always want you to put the first number on top and the second number on bottom. Except when it deals with money, like these two. When it deals with money, where does the money go? Money goes on top. Okay, so let's go back to our lollipops. 50 lollipops. I'm just going to write an L because that's a long word. In 4 hours. Okay, we need to simplify this. So, let's see. They're both divisible by 2, so let's go ahead and divide by 2. 50 divided by 2 is, oh wait, actually, sorry. We don't need to simplify this. What we need to find is the unit rate. My bad. Whenever you're finding the unit rate, the easiest, fastest way to do this is take the top number and divide it by the bottom number. So let's just do that. So 50 divided by 4. And that gives us our unit rate, 12.5. So 12.5 lollipops per hour. Okay, and that's your answer right there. Let's go ahead and do number 11. 250 apples for 40 pies. Okay, we're going to put this number on top. 250 apples. And then 40 pies is going to go on the bottom. Okay, now we're just going to divide just like we did over here. So the top number divided by the bottom number. And that's going to tell us how many apples go in each pie. So 250 divided by 40. 250 divided by 40 gives us 6.25. 6.25 apples per pie. Okay? So it's always the top thing per the bottom thing. So here it's apples per pie. Over here it was lollipops per hour, okay? So apples per pie, 6 1/4 apples per pie. Let's look down here. Now you have 5 pounds of walnuts for $12.35. Like I said, in this case, you have price, you have money of dollars. The dollars are going to go on top. So $12.35 divided by 5 pounds. Now, when we set it up this way with the money on top, what it's going to do is it's going to tell us how much money per pound. And that's a very useful thing. So we know how much 5 pounds of walnuts cost. Let's figure out how much 1 pound of walnuts going to cost. Okay, so $12.35 divided by 5. So it looks like the cost of 1 pound of walnuts is $2.47. $2.47 per pound. And I'm just writing LB to, what's that called? Abbreviate for pounds. Okay, so there's your answer there. Let's go over here. 4 liters of pop for $5.34. Same idea here. Dollars go on top. So $5.34 and 4 goes on the bottom. Okay. Now 5.34 divided by 4 should give us the unit rate. It says 1.335. Remember the instructions said to round to the nearest hundredth. So here's the hundredth place is that second 3. So I'm going to look over here to the thousandth place, and if it's 5 or higher, I'm going to bump the hundreds up. It is 5 or higher, so this 3 is going to become a 4. 1.34. And what does that mean? That means $1.34 per liter of pop. You can just write per liter though, that's totally fine. Okay, there's that section. Alrighty, so we're going to do some more unit rate in the next section. It says, find the unit rate to the nearest penny, label with correct units, and put a check by the best deal. Okay, so we've got some comparison shopping here, just like we're at the grocery store, right? So we have 4 liters for $3.29 or 7 liters for $5.79. This problem is exactly like this one. So if you want to hit pause real quick and try it by yourself if you haven't already, that would be awesome, and then compare with me in a second. Okay, so 4 liters for $3.29. We'll put the money on top and the number of liters on bottom. So $3.29 divided by 4. $3.29 divided by 4, it gives us, let's see, rounding to the nearest cent, it's 0.82. So basically 82 cents per liter. Okay, what about 7 liters for $5.97? We're going to put that $5.97 on top and the 7 on bottom because we always put money on top. And then we're going to divide. Let's see, 5.97 divided by 7. That's going to give us, rounded to the nearest hundredth, 85 cents. So 85 cents per liter. So which one's the better deal? 82 cents per liter or 85 cents per liter? When you're looking for the better deal, you always want the lowest number. So this one is the better deal. Now, if you're looking like for the fastest car or something like that, if you're looking for fastest, then you would want to put the check mark by the higher number. But when you're looking for the better deal, you're always looking for the lower number, assuming you're looking at the dollar amounts. Okay, let's look at the next problem. We have more money stuff. So again, money's going to go on top. Let's set this up really quick. 10.34 for 20 ounces. And then over here, it'll be 6.15 for 12 ounces. Let's divide really quick. 10.34 divided by 20. Okay, so rounding, the 7's going to bump that 1 up to a 2. So I'm going to say 52 cents. So 0.52. Okay, what about over here? 6.15 divided by 12. Okay, it looks like it's just going to stay at 51 because the 2 will not bump that up. So 51 cents. Boy, those are close. But which one's the better deal? What's the lower number? It's going to be this one right here. Okay, cool. And that's all you have to do for that section. Now, I got a little lazy there and didn't really write my units. This should say per ounce. They both should, okay? Just to be thorough and complete. Let's go to the next section. It says find the unit rate. Use the correct labels on your answer. Okay, this is where we get to build the giant fractions. Okay, let's do this. So 3/4 of a pizza for 3/7 of a class. I'm just going to put that first amount on top and the second number on bottom, and that's going to tell us how much pizza per class. That sounds like a useful amount, right? Okay, so 3/4 on top, 3/4 pizza, and then 3/7 on bottom. So this, like I said, is going to tell us how many pizzas per class. That is more intuitive, more obvious than figuring out how many classes per pizza. For one thing, I'm sure a class could probably eat more than one pizza by themselves. Let's go ahead and solve our problem. So this is a keep, change, flip situation. So we're going to keep the 3/4. We're going to change the division into multiplication. And we're going to flip the last fraction, 7/3. And now, I mean, you could use a fraction calculator if you want, or you can just kind of cancel a little bit. You see the 3 and the 3? Those are going to go to a 1. Now, how did I do that? I saw that they're both divisible by 3, and I divided by 3. So 3 divided by 3 is going to be 1. Same thing here. You can only do that with the diagonal numbers, okay? Now, diagonally here, the 4 and the 7, they don't have any factors in common, so I'm just going to leave them alone. When I multiply, I'm going to get 7/4. All right, that is fully simplified. So that all I have to do now is write the units. What are the units here? It's pizzas per class. So 7/4 pizzas per class. Right there. Let's go ahead and do number 17. We have 4/9 of a lawn and 1 1/3 of an hour. Okay, so we're going to figure out how many lawns per hour. So 4/9 lawns in 1 1/3 hours. Now, whenever you have a mixed number, you want to go ahead and change that to an improper fraction. So what's that going to be? 3 times 1 is 3, plus 1 is 4. So this will be 4/3. And that's what I'm going to write down here, 4/3 hours. Okay, once again, keep, change, flip. Let's do it. So we're going to keep 4/9. We're going to change the division into multiplication, and we're going to flip the 4/3. It's going to become 3/4. Can I do any cross-canceling here? By the way, if you don't like cross-canceling, you do not have to do it. You can just multiply it out. 4 times 3 is 12. 9 times 4 is 36. And then simplify from here. That's totally fine. But I like to cross-cancel, so I'm just going to show you that. 4 and 4 are both divisible by 4, so let's do that. And they'll both become 1. And now 3 and 9 are both divisible by 3, so let's do that. This will become 1. This will become a 3, because 9 divided by 3 is 3. And when you multiply across, 1 times 1 is 1, and 3 times 1 is 3. Is this the same thing as this? Yes, it is. They're exactly the same. It's just that this one is simplified. So I circled it a little too soon. I need to write my units, don't I? So 1/3 lawns per hour. Okay. There we go. Let's go on to the next section. Numbers 18 and 19. It says, write the equation that represents each situation. Explain what the variables represent. Let's do that. It takes Samantha 1 hour to run 4 miles. Okay, guys, you could make a case for this either way, and I'm going to make sure that your test is crystal clear. So if you interpret this to mean how many hours it takes per mile, then you would put your hours on top and your miles on bottom. But if you interpret it to mean, should we find how many miles per hour, then you would put the miles on top. I'm going to do it both ways, okay? So if you want to find hours per mile, this is probably the less common situation, but because the problem's written this way, I just want to do it this way. How many hours per mile? So 1 hour per 4 miles. That unit rate, you're going to do 1 divided by 4, and you're going to get 0.25. Okay, and then you would put it in the equation. You would go y equals 0.25x. Now the important part here is that you explain your variables correctly. So make sure that x, you take that from the units that were on the bottom. What was on the bottom here? Miles. Okay, so X is going to be miles. The Y is going to be the unit on top, which was the hours. So Y is going to be hours. Okay, so this is one way to solve this problem right here. I'm going to change colors. Let me grab my red pen here. And we'll solve it the other way. If you want to find miles per hour, then here's what you would need to do. You would do 4 miles per 1 hour. Now, when you divide that, what do you get? You just get 4. So this is the number right here that would go inside your equation, and it would be y equals 4x. And your x, your variables are going to be flipped, okay? So your x is going to be the bottom, which means hours. X is hours, and y is going to equal miles. So really the answer to this depends on what information you're looking for. If you have this one, make sure you have the correct x and y over here. If you have that one, you are correct. Good job. If you have this one, again, make sure you defined your variables correctly. If you have that, you are correct also. Good job. Let's go on to number 19. I don't know why this one looks so blurry. Let me see if I can focus that a little bit more. Maybe a little better. Okay, Dominic can mow 12 lawns in 5 hours. This one seems really straightforward to me. We're going to do how many lawns per hour, okay? Lawns per hour. So, lawns on top, hours on bottom. 12 lawns per 5 hours. We're going to just go ahead and divide that out. Let me write my units here. So how many? 12 divided by 5. Whoops, my calculator went to sleep. 12 divided by 5. That's how much I'm talking over here. 2.4. So that means 2.4 lawns per hour. Now let's put that into our equation. Always starts with y equals every single time. No matter how things get flipped around, this you can count on. It starts with y equals, and then you put your number in here. Your unit rate goes in there. And then we're going to put the x after that. Okay, so every time you write these fractions, it'll be y equals, and then some number, and then an x. So if you can remember that, you are really halfway there. So we have y equals 2.4x. Now let's define our variables. So the x, that is the one that was on the bottom. What was on bottom? Hours. So x equals hours. Y was the one on top, so y equals lawns. So what do you need for your answer? You need this part. That's your answer. But make sure that you're showing me your work on the test when it comes time to take it. It's important that I can kind of see your thinking and see your steps. And I know a couple of you, a few of you have just given me only the right answer. And I've actually sent it back and said, hey, I need to see your work. So just make sure that you're showing me your work on your test so that I can give you full credit the first time. Okay, as far as 21 and 22 go, you don't have to worry about those. And yeah, that's it for your review. Thanks for watching. Let me know if you have any questions, and I'll see you next time.